Hello, and welcome to today's lesson on constructing ray diagrams for reflection. In today's lesson, we will learn how to construct ray diagrams to illustrate reflection. We will identify and label the key elements such as the incident ray, reflected ray, and normal line. So far, we have delved into the concept of reflection, understanding how waves change direction when they encounter a reflective surface. Building on this foundation, we can now explore constructing ray diagrams to visually illustrate how reflection occurs. Let's get started by taking this theory and applying it step by step to see how waves behave when they encounter a reflective surface. We'll begin by representing the reflective surface where the reflection occurs. Use a ruler to draw a straight horizontal line across your paper. This line symbolizes any reflective surface, such as a mirror or a smooth body of water. Next, we will draw the incident ray. This ray represents the incoming wave. With your ruler, draw a straight arrow pointing towards the surface from the left. This arrow represents the direction in which the wave is traveling before it hits the surface. Now that we have our surface and incident ray, let's establish the critical point of measurement, the normal line. At the point where the incident ray meets the surface, draw a perpendicular line, known as the normal line. This line helps us measure angles and ensures our diagram is accurate. Be sure to use a protractor to get the 90-degree angle right. With the normal line in place, we can now focus on measuring the angles of incidence and reflection, key to understanding reflection's principles. Now, we'll measure the angle between the incident ray and the normal line. Position your protractor so that it aligns with the normal line and the incident ray's direction. The angle you measure is called the angle of incidence. Label this angle clearly, as it's essential for the next steps. According to the law of reflection, the angle of incidence is equal to the angle of reflection. With that in mind, measure the same angle on the other side of the normal line, and draw an arrow indicating the reflected ray. Finally, use your protractor to measure the angle between the reflected ray and the normal line. Label this angle as the angle of reflection. This should match the angle of incidence. By following these steps, you'll have an accurate ray diagram illustrating how waves reflect. With these elements in place, we've successfully constructed a ray diagram, a visual tool that helps us grasp how reflection works in real-world scenarios. In today's lesson, we learned how to construct ray diagrams for reflection. We visualized the reflective process by drawing the surface, the incident and reflected rays, and the normal line, while accurately measuring and labeling the angles of incidence and reflection. Understanding these diagrams is crucial as they are foundational in analyzing more complex wave behaviors. We will be applying our new skills to the real-life example of mirrors in the next lesson. Watch the rest of the GCSE physics course at Sophos Education.